Imagine building a house on sand. You would want that sand to be strong and tightly packed, right? That's where the density of sand comes in. It's a big deal in construction. This is because sand acts like a foundation for many structures. If the sand is too loose, the building might sink or become unstable. But if it's too dense, it might not settle properly. Knowing the density helps engineers make sure the sand is just right for the job. It's all about safety and making sure buildings are strong and long-lasting. Think of it like baking a cake. You need the right amount of each ingredient for it to turn out perfectly. Too much flour, and it's dry. Too little, and it's gooey. Sand density is like finding that perfect balance for buildings and roads. So, what exactly is sand density? Simply put, it's how much sand is packed into a certain space. Imagine a jar full of marbles. Now imagine another jar of the same size, but this time it's filled with sand. The jar with sand will be heavier because sand packs more tightly than marbles. That's what density is all about, how much stuff is crammed into a given area. In construction, we measure sand density to understand its compactness. This helps us determine if it's suitable for different construction needs. For example, the sand used for making concrete needs to be denser than the sand used for filling a playground. Understanding density ensures we use the right type of sand for the right job. Now, how do we figure out the density of sand? There's a specific test for that. It's called the sand density test, and it's like a science experiment on a construction site. First, we collect a sample of sand. Then, we measure its weight and volume very precisely. We use special tools to make sure our measurements are accurate. By dividing the weight of the sand by its volume, we get its density. Think of it like figuring out how much your backpack weighs when it's full of books. You know the weight of the books and the size of your backpack. Sand density testing is similar, just with more precise tools and measurements. Section 4. Exploring different sand density measurement techniques. Just like there are many ways to bake a cake, there are different ways to measure sand density. Each technique has its own advantages and is suited for different situations. One common method is the water displacement method. It involves submerging a known volume of sand in water and measuring how much water is displaced. This helps us calculate the sand's volume accurately. Another method is the sand cone method, where we dig a small hole in the sand and fill it with a known volume of standard sand. By comparing the weight of the excavated sand to the standard sand, we can determine its density. Then there's the nuclear density gauge method, which uses gamma rays to measure density. It's a faster and non-destructive method often used for large-scale projects. Section 5. Ensuring accuracy for safety and quality. Getting the sand density right is crucial for construction safety and quality. Imagine building a bridge on sand that's not dense enough. The consequences could be disastrous. That's why accurate sand density measurement is non-negotiable. By ensuring accurate measurements, we guarantee that structures are built on solid foundations, minimizing the risk of collapses, cracks, or other structural problems. It's about building with confidence, knowing that our structures are safe and durable. Accurate density testing also helps prevent material wastage. If we know the exact density required, we can order the right amount of sand, saving costs and reducing environmental impact. It's about building smart and sustainably. Section 6. The future of sand density testing in construction. As technology advances, so do the methods for measuring sand density. We can expect to see more sophisticated and efficient techniques emerging in the future. These advancements will make the testing process faster, more accurate, and less labor-intensive. Imagine using drones equipped with sensors to map out the density of sand across an entire construction site in minutes. Or handheld devices that provide instant density readings with pinpoint accuracy. The future of sand density testing is exciting, promising safer, more efficient, and more sustainable construction practices. By embracing these advancements, we can continue to improve the quality and safety of our built environment, creating structures that stand the test of time.